Hello everyone, welcome back to our channel. This is Dr.Nazma and in this video we are going to discuss the NCERT solutions of the chapter Some Basic Concepts of Chemistry. So there are so many questions, because of which I had to divide the videos into parts. So part 1 will be consisting of first a few questions and we'll continue the rest of the questions in part 2 and part 3. Let's get started without any more delay. These are the exercise questions, not in-text questions. Please keep that in mind. Question number 1.1 in fact, is to calculate the molar mass of the following molecules given. First one is H2O, second one is CO2, and third one is CH4. As you all know, molecular mass of any given molecule can be calculated by summing the atomic masses of all the elements given in the particular molecule. Say for example, I'm talking about H2O. In case of H2O, I'm having 2 hydrogens and 1 oxygen. So I just need to sum up the atomic mass of hydrogens, 2 hydrogens and 1 oxygen atoms. For 2 hydrogens, atomic mass is going to be 2 into 1 atomic mass unit. For 1 oxygen, it's going to be 1 into 60. Which altogether will be 2 plus 16, and it is 18 atomic mass units. So the molecular mass of H2O is 18 atomic mass units, because molecular mass is the sum of atomic masses of all the elements present in your molecular formula. Very similarly for rest of the molecules. Carbon dioxide has 1 carbon and 2 oxygen atoms. So 1 into atomic mass of carbon into 2 plus 2 into atomic mass of oxygen is what you need to consider. So atomic mass of carbon is 12.001, but then you can consider this to be 12 to round up. Now atomic mass of oxygen is 16, because you have 2 oxygen atoms, you are taking it as 2 into 16. So altogether it is 12 plus 32, which is 2 into 16, and it is 44.01 atomic mass units. You can also write it as 44, doesn't make any difference. Your answer will be correct and you'll get full marks. Now finally, CH4, the third molecule. You have 1 carbon atom and 4 hydrogen atoms in the given molecule. So 1 carbon atom's atomic mass plus 4 hydrogen atoms atomic mass is what can give you the molar mass of CH4, which in turn is 1 into 12, that is atomic mass of carbon, plus 4 into 1, that is atomic mass of hydrogen. When you simplify this, your answer will be 16 atomic mass units. So this is how you calculate molecular mass. So calculating molecular mass is one of the very important points in learning chemistry, irrespective of the chapter or irrespective of the topic. So molar mass calculation can happen this way. We are done with the first question. Let's move on to the second question. So second question is over here. Calculate the mass percent of elements present in sodium sulfate. This is question 1.2. So how to calculate the mass percent of different element present in any given molecule with the help of this formula. So the formula to calculate mass percent is equal to mass of that particular element, whose ever mass percentage is being calculated, divided by molar mass of the entire compound into 100. A few points that you need to get clarity about over here. 1. Mass of the element. Say for example, you are talking about given molecule, which is sodium sulfate. So in sodium sulfate, you are asked to calculate the mass percentage of sodium, sulfur and oxygen. When you are calculating mass percentage of sodium, in the numerator, you will be taking the mass of sodium with respect to this molecule. So you have 2 sodium atoms. So in the numerator, you will be taking 2 into 23. 23 is mass of 1 sodium. Since you have 2 sodiums over here, you are taking 2 into 23. Similarly, if you are calculating mass percentage of sulfur, you will be considering the mass of sulfur in the numerator. Since you have 1 sulfur, which will be weighing 32, you're going to take 32 in the numerator. And now when you talk about mass percentage of oxygen, you have to take 1 oxygen into 4 into count, because in this molecule, with respect to which you're calculating mass percentage, there are 4 oxygen atoms. So it is 4 into the mass of oxygen, which is 4 into 16, which altogether is equal to 64 units. So in the numerator, you will be taking 64. Okay. And now let's apply the same to the formula and let us simplify. For the first one, which is for sodium, Sodium atomic mass is 23, but since you are having two sodiums, it is 46 divided by molar mass of compound. We just have discussed how to calculate molar masses. But anyways, once more, molar mass of sodium sulfate is the molar mass of two sodium atoms that you have plus the mass of one sulfur plus mass of four oxygen atoms, which is 2 into 23 plus 1 into sulfur, which is 32, plus 4 into 16, that's for oxygen. Altogether is 142. It's not really necessary that you stick to these decimals, but then I have shown it up over here just for your reference. So it is 46 divided by 142 into 100 when you substitute the figures into the formula to calculate mass percentage. So here you're calculating mass percentage of sodium. It's mass of sodium by 142, which is total mass of compound into 100. When you simplify, this is what is your answer, 32.4. So now same thing for sulfur. Mass percentage of sulfur. As discussed before, in the numerator, when you're calculating mass percentage of sulfur, you'll be taking the mass of sulfur, which is 32. In this molecule, in sodium sulfate, you have 32 grams of sulfur divided by molar mass of sodium sulfate is 142 into 100. When you simplify, it's 22.6. And now finally for oxygen, you try doing it without saying, you try doing it on your own efforts. But anyways, if you are stuck up, listen to me carefully. The mass of oxygen divided by mass, molar mass of the compound, molar mass of sodium sulfate into 100 is what is the formula. But mass of oxygen is 64 because sodium sulfate, as per its formula, has 4 oxygen units, because of which you are calculating 4 into 16 as mass of oxygen. So it is 64 by 142 into 100. On simplification, it is 45.05%. Fine. So this is how you calculate mass percentage. This formula is important, and let's move on to the next question, number 1.3. I hope you are all able to follow and understand what's happening here, but in case you're stuck up, please let me know your questions or doubts in the comments. So the question 1.3 says, determine empirical formula of an oxide of iron which has 69.9% of iron and 30.1% of dioxygen, which is nothing but O2, by its mass. So now the question is about determining empirical formula. And they're saying that it's a metallic oxide in which the metal iron is 69.9% by mass and the oxygen is 30.1% by mass. So while calculating empirical formula and molecular formula, there are a few steps that you need to keep in mind. We are first of all writing those steps and then we'll come to solve this question. So step number 1. Step number 1 is take down the percentages clearly. I have 69.9% of iron and 30.1% of oxygen. So first step is identifying the percentages and identifying the mass of the metal and the oxygen. So what is the mass of iron? Iron's mass per 1 mole of iron, it is 55.85. And for 1 mole of oxygen, it is 16. So in the second step, what am I doing is I'm dividing this mass percentages with the atomic masses of the elements. Iron's atomic mass was how much? It is 55.85. So I'm 55.85 I'm taking over here. And now oxygen's atomic mass is 16. I'm taking 16 over here. So in step 1, I'm identifying the mass percentages that are given and dividing the mass percentages with the atomic masses of those particular elements. Now in the second step, first of all, in first step, since you're taking the division, you have to simplify it. Once you simplify, the values that you obtain are over here, 1.25 and 1.88 respectively. Here you have 1.25, here you have 1.88. Okay. So now what you have to do in the second step is identify the least one out of what you have acquired. I have acquired 1.25 and 1.88. Out of these two, which is the least? Least is 1.25. So now consider 1.25 and divide both the values by that 1.25 itself. And why are you dividing by 1.25 itself? Because I'm dividing the resultant of step 1 by the least value that I have acquired. And when I do so, I'll be getting 1 over here, but here I'll be getting slightly more than 1. Even here in the solution, the same thing is solved, but in a different way. I'm giving you a shortcut method. Fine. So when you do so, you are going to have what? You are going to have 1 over here, and here you will be having around 1.25 or maybe 1.5 after getting rounded up. Okay. So this is second step. Same thing is represented over here. You have taken the percentage mass of iron and oxygen, you have divided them by atomic mass, then you have gotten the values and you have divided the values by the least possible so that you get a simplest ratio. But when you look at the ratio is not consisting of whole numbers. Now I want the ratio to consist of whole numbers. So what do? I do multiply this ratio with a suitable number, with a simple suitable number, so that I avoid these decimals. So we can multiply this with 2. We can multiply this also with 2. You have to multiply both the figures with the same number. When I multiply this with 2, I'll have 2 in the answer, I'll have 3 in the answer. So now if I can multiply both the values with the same number 2, I can get the result which is not a decimal figure. So it is 2 and 3 after multiplying with 2. So the same ratio is multiplied with 2. And when I do so, it is 2:3. What is this? This is nothing but the number of atoms of iron and oxygen respectively in the empirical formula. So I'm having 2 irons and I'm having 3 oxygens, as it's already written over here in the empirical formula. So these are the 3 steps. Just in case if you are not very clear about how to do it, I'm solving it once more. Not solving it, but I'm giving you the steps once more. In the first step, you're taking the percentage mass and you're dividing it by atomic mass of the particular element. And you will get some value over here, right? So whatever answer you have gotten in the case of iron and in case of oxygen, compare them and observe them. Whatever is the least, you have to take that least value and divide the answers that you have obtained by that least value. And when you do so, you will get another figure over here, y. Make sure the y is converted into whole number by multiplying with a simple suitable number. So that in turn will give you what? That in turn will give you the number of atoms of each element in the empirical formula. I hope this helps you. If in case you have not understood this, please don't hesitate asking me to explain again in the comment section. Let's move on now. The empirical formula of iron and oxygen is Fe3O3. That is the answer of this question. We are moving on to question number 1.4. So in question number 1.4, it has 3 parts. The first one is calculate the amount of carbon dioxide that could be produced when 1 mole of carbon is burnt in air, when 1 mole of carbon is burnt in 16 grams of oxygen, dioxygen, when 2 moles of carbon is burnt in 16 grams of dioxygen. So they are talking about the same reaction, burning carbon in presence of oxygen to give you carbon dioxide. But if you observe the balanced chemical equation, 1 mole is the molar ratio of reactants and products, and you can also convert it into grams, which means 12 grams of carbon is reacting with 32 grams of oxygen to give you 44 grams of carbon dioxide. Let's once more take a look at the first question. The first question is 1 mole of carbon burnt in air. So as per the chemical equation, as per the balanced chemical equation, 1 mole of carbon is anyways being burnt in air. And what is the amount of carbon dioxide produced while this have happened? 1 mole of carbon is burning in air to give you 1 mole of carbon dioxide. So answer for first part of the question is 1 mole itself. I hope you are able to follow, but in case you have doubts, please ask me in the comments. And now let's look at the second part of the question. This time you're taking 1 mole of carbon, but then you're burning it in 16 grams of dioxygen. If you look at the balanced chemical equation again, when you're taking 1 mole of carbon, 1 mole of oxygen is needed, which is 32 grams by mass. 1 mole of oxygen molecules is equal to 32 grams. But now in the second part of the question, they are asking you to consider only 16 grams. So now if 1 mole of carbon can burn in presence of 32 grams of oxygen to give you how much? 44 grams of carbon dioxide. When you take 1 mole but then only 16 grams of oxygen, how much of carbon dioxide will be produced, right? So they are asking you to calculate the amount of carbon dioxide for every part. So you're calculating how much carbon dioxide is produced even here. If 32 grams can give you 44 grams of carbon dioxide, 16 grams can give you how much? You simply need to cross multiply here. It will be 16 into 44 divided by 32. I hope you all know the unitary method. So this on simplification will give you 22 grams. So you'll be having 22 grams of carbon dioxide produced. So as per the balanced chemical equation, 32 grams of oxygen can give you 44 grams of carbon dioxide. 16 grams can give you how much? Cross multiply and find out the answer. So answer for the second part is 22 grams. Now let's go back and read the third part. When you take 2 moles of carbon in 16 grams of oxygen, then what is the case? 2 moles of carbon, 16 grams of oxygen. But then observe something here. You're talking about 1 mole. 1 mole of carbon is requiring 32 grams of oxygen. Now if you have 2 moles, technically you should be having how much of oxygen? You should be having 2 into 32 divided by 1, which is 64 grams of oxygen is needed. This is what is needed. If you don't have this much of oxygen, the reaction can't proceed forward. Correct? But then look at the question. We are talking about 2 moles of carbon but only 16 grams of oxygen. So oxygen is present in very limited quantity here. So now you call oxygen as limiting reagent. If you remember the concept of limiting reagent, I'm sure you also remember that the product formation happened with respect to the quantity of limiting reagent that is available. So now you need 64, you don't have 64. So oxygen is limiting reagent. You got to calculate the amount of carbon dioxide with respect to oxygen. So as per balanced chemical equation, 32 grams of oxygen can give you 44 grams of CO2. But now you only have 16 grams. So how much of carbon dioxide will be furnished? It is 16 into 44 divided by 32, which is 44 by 2, which is 22 grams. Even if you have 2 moles of carbon, because you have only 16 grams of oxygen, which is a limiting reagent, you can only synthesize 22 grams of carbon dioxide, but you can't get more than that. That's what the question means. So answer for the third part of the question is 22 grams of carbon dioxide. So this is how we solve the questions based on mole concept and stoichiometry. This was about question number 1.4. Now let's go to question number 1.5. Let's read the question first. It is calculate the mass of sodium acetate. Formula is given already. So calculate the mass of sodium acetate required to make 500 ml of 0.375 molar aqueous solution. The molar mass of sodium acetate is 82 grams per mole. Now since there is a lot that's been given in this, let's write the data. Whenever you're solving the numericals, if the numerical is a bit complicated, first write the data to avoid confusion. So you got to calculate mass of sodium acetate. You got to calculate mass of sodium acetate. So sodium acetate mass is how much? To make a volume of 500 ml and a molarity of 0.375 aqueous solution. You know volume, you know molarity. And you also know the gram molar mass of sodium acetate, which is 82. I'm taking a rounded up figure, 82 grams per mole. So what you need to calculate is mass. So since you know molarity, you know volume, you also know gram molar mass, you can try to consider the formula of molarity. If you consider the formula of molarity, molarity is equal to N by V. N is number of moles, which is weight by gram molecular weight into 1 by V, volume in liters. So now, as per the question, you are supposed to calculate mass. So you don't know what W is. You got to calculate W. But then you know what molarity is. Molarity is 0.375. So 0.375 is equal to X, which is mass, which I don't know, divided by gram molecular mass, which is 82 point something, but I'm taking it as 82 here, into 1 by V. V is volume. Volume has been given in ml, but I'm saying that you have to take volume in liter. So what am I doing is I'm converting this into liters. I'm writing 0.5. So you just got to rearrange this and simplify. When you got to simplify, you will be having 0.375 into 82 into 0.5, which altogether on simplification will be 15.38. So the required mass of sodium acetate is 15.38. I hope this is also clear. With this, we have completed the first 5 NCERT solutions from the chapter Some Basic Concepts of Chemistry. We'll be continuing from 6th question onwards in part 2 of the video. I hope you are understanding this, but in case you're not, in case you have some doubts, please make sure you let me know in the comments. I'll see you in one other video. Until then, bye-bye.